All right, this is our day kind of to go over some notes and recap the 3 Desmos lessons we did last week. That's the purpose of today's video and our lesson. This is just a quick little overview of what we're going to be doing in this video. And in class, just revisiting what is the proportional relationship, how can we see it in a table, in the table can we find missing values, and then we're going to go back to a term we talked about last week, constant of proportionality, and then there'll be time to work. All right, so on this slide, it's just a reminder that we're going to explore proportional relationships. And they're really all over the grocery stores, recipes. If you buy 1 pound of tomatoes, that's $2.49. If you were to buy 0 pounds of tomatoes, how much would you pay? You'd pay 0. So just remembering things like that. And if you were to double your pounds, you would double the price. All right. One way to tell if things are in a proportional relationship is you can ask yourself these questions. So you have, in your notes, you have a fill in the blank, and you can say, well, if I double one thing, will the other thing double? For example, if I double the height in feet, should I also double the inches, what it would be in inches? And that would be true. Or you're doing a recipe. If I triple the milk in the recipe, should I triple the flour also, so that I keep the same recipe? So these are really good questions to ask to make sure to see if the relationship is proportional. Let's practice seeing if we can identify whether a situation is in a proportional relationship. All right, here's an example. The number of Oreos that you eat and the amount of sugar you consume. So let's use our double test. If I were to double the amount of Oreos I ate, would I double the amount of sugar that I also eat? And I would say yes. And what if I ate 0 Oreos? I would have 0 sugar from them. So on this one, I would say yes. Yes, this is proportional. All right, here's another one to look at. How many hours you've been at school and how hungry you are. Let's do the double test. If I double the hours I've been at school, will that double my hunger? Will that stay consistent? If I'm not, if I have 0 hours at school, will I have 0 amount of hunger? I would say this is not proportional. How many hours you were at school will vary, and how hungry you are during the day will vary on different things other than how many hours you were at school. All right, another one to look at, the number of cookie grams that you buy and the amount of money you have left. So this is a little different than saying the amount of money you spent, the amount of money you had left. So if you start with $20 and you buy cookie grams, you buy 15 cookie grams, you only have 5 left. I don't think this is going to pass our double test, but let's try. If I double the amount of cookie grams I buy, would that double what I have left? I don't think so, because eventually you're going to run out of money when you buy them. So on this one, I'm going to say no, it is not proportional. All right, let's look at our last one. Your age in months and your age in years. So let's try the double test. If you're 1 year, if your age is 1 year old, that would be 12 months. If I doubled that, that would be 2 years and 24 months. So when I double my years, I also would double my months. And if you're 0 years old, you would be 0 months old. I would say yes to this one. Yes, it is proportional. All right, on the next couple slides, we're going to look at a recipe for making cinnamon sugar found in the Spruce Eats website. We're going to look at a table and see if from the table if we can tell if the relationship is proportional. All right, so what we're going to do to test if it's proportional is look at equivalent ratios or equivalent fractions and see if they stay the same. So what I'm going to do is start by comparing my cinnamon to sugar and see if they stay consistent. All right, well, I start with my first ratio, 1 cinnamon to a half cup sugar. And I compare it to my next one, and I say to myself, you know, all they did here was they multiplied it by 3. So again, we go back to if I triple the cinnamon, did I triple the sugar? And I would say yes, I did. So we can continue to do that. Let's try again. All right, let's compare the first entry with the third. So what would I times 1 by to make 8? So if I were to multiply the cinnamon by 8 and make it 8 times the amount, I would have to do that to sugar, and half of 8 is 4. So to me, I'm going to say yes, this is proportional. What I want to point out on this other side is that it does not matter which direction you make your ratio. So if you were to say cinnamon to sugar, you could check sugar to cinnamon and just set it up this way. The same rules apply. If I triple the sugar, I should triple the cinnamon. And if I look, it does work. All right, I like this slide. What is going on here? Kids who were in class when I had students stand up and one student would take 2 steps and the other would take 1, they understand what I'm talking about, that not only do proportional relationships have to have the same ratio if you reduce it, okay, or be able to double or triple. Not only do they need that, a proportional relationship will go through 0, 0. Think of it this way. If you have 0 cinnamon, you would add 0 sugar because you wouldn't want to change anything. So if you don't have any cinnamon, you won't have any sugar, you won't even make the recipe. All right, I would like you to hit pause. I want you to try and find out which of these tables are showing a proportional relationship and which are not. And so hit pause, and then you can resume watching and watch me go over these tables on the next 3 slides. All right, let's see how you did. Okay, well, I like how this one starts with 0, 0. That's a great start. Then we have 2 dogs. The cost will be $4.40. So let's do if I double one side, will I double the other side? So 2 times 2 is 4, but 2 multiplied to $4.40 should be $8.80. Whoa, hold it. So I'm going to say no. I'm going to say no. This table is not a proportional relationship. All right, let's try table 2. I like what I see. I like 0, 0. And even if 0, 0 is not in the table, you could check it and check all the others to make sure. We'll talk about that later. But let's start here. What do I multiply 1 by to make 0.6? I'm going to multiply it by 0.6. And if I multiply 5,280, which is how many feet are in a mile, by 0.6, I do get 3,168. I could double check here too. What do I multiply 1 by to get it to 0.1? I multiply that by 1/10. And if I do that here and multiply by 1/10, 1/10 of this number is 528. I'm going to say yes, this is a proportion. Okay, on this third one, it gets a little tricky. It starts off pretty good, 1.25. If you multiply the height in feet and the tree age, it works. Multiply by 2, it works. And then here we multiply 0.7 to 10, and we do get 7. Then, when we multiply here, we do not get 12.9, we get 12.6. So this is a no. This is a no. So the reason for this slide is to make sure if you check each value to double check to make sure it is or it isn't proportional. On these next few slides, we're going to explore if we know that a relationship is proportional, how can we find the missing values? So we're going to explore a couple ways to do that. One way is how we started with the idea of proportionality. If I triple one side, I should triple the other side. So 3 times 2 is 6. 3 times 7 would be 21. I can check on the last number here also. I could use 6 or 2. I chose 2. I divided 3.4 by 2 and found out 2 goes into this number 1.7 times. That's my scale factor. And so I'm going to use that here to keep it balanced and proportional. 7 multiplied to 1.7 is 11.9. All right. And we can get both sides of the table. Same method. I say to myself, what do I multiply 7 by to make it 52.5? So I divide 52.5 by 7. That's a scale factor of 7.5 times larger. And if I multiply that to the 2 to keep it balanced, I get 15. All right, let's look at another method we can use to find missing values in a table. It's the constant or constants of proportionality. And just like when we are exploring scale and scale factor, what you can do is you can say, to go from A to B, I want to find out what I multiply by to go from A to B. What you can do is divide B by A to find that. So I'm going to put B, which is 7, on top of 2. 7 divided by 2 is 3.5. That means my constant of proportionality to go from A to B is to multiply by 3.5. So all I need to do to find the missing B value is to take the A value and multiply it by 3.5. If you were to look back at your notes from the slide earlier or previous, we do get the same answers. So both methods will give us the same answer. Now we're going to, how do we go from B back to A? So to go from B to A, what I'm going to do is take A and put it over B. All right, so I'm going to take 2 and put it over 7. So my scale factor to go the other way is to multiply this 52.5 by 2 over 7. And I get 15, and again, this answer matches the previous slide. All right, we're going to dive deeper into constants of proportionality. I think you heard me in class maybe call it a unit rate. When you divide 4 by 8 or 1/2 by 1, you are finding out how many cups of sugar it would take for 1 cinnamon. So fill your notes in, but there is or are 1/2 cup, a 1/2 cup of sugar for every tablespoon of cinnamon. This is a unit rate because we're finding out how much sugar for one cinnamon. And now that we know this, this is what we can multiply by to go from cinnamon to sugar. We can say, what's half of 3? 1.5. What's half of 8? 4. And half of 0 is 0, which that's a good thing too. Now we're going to look at going the other way. So we need to figure out how much cinnamon there would need for 1 cup of sugar. What I did here was I just said to myself, what can I do to make this 1/2 cup a whole cup of sugar? And I doubled it. I times it by 2. So if I times 2 to 1, I get 2. So it looks like for 1 cup of sugar, I'll need 2 tablespoons of cinnamon. So fill in your table. And again, it has to do with what do you need. Does it make more sense to know what 1 cup of sugar is for, or does it make more sense to know what 1 tablespoon of cinnamon would require? And we'll talk more about that in other situations later in this chapter. All right, hit pause, and I want you to try and write a couple statements using proportionality and the constant of proportionality. Try and find out, write a sentence involving the 1 mile, and then for a more challenging, figure out how many miles would be in 1 foot. Hit pause and try. All right, check your answers. The first one's pretty easy. There are 5,280 feet for every 1 mile. Yep, that's true. The other one's harder, so remember to go from B to A, you have to divide A by B, or make a fraction of 1 over 5,280. So there is 1 5,280th of a mile for every foot. That one, a little trickier, and we probably wouldn't use it very often. All right, I hope the notes helped. You do have an assignment in Desmos. I would like you to go and start doing that right now. All right, take care.